So now we're going to look at three different ways that energy is transferred. So that's looking at radiation, conduction, and also convection. So what we can do is let's start with conduction. So conduction is when vibrating particles transfer energy to their neighboring particles. So if we look at this metal block and a Bunsen burner, when one end of the metal is heated, then because the particles are in like this in a solid arrangement, they transfer throughout this metal. Um, and they start off on one end, which causes them to vibrate and collide with their neighboring particle with more energy, and then eventually the whole metal heats up. So it's through the collisions that with the neighboring particles that this happens. And as this process kind of goes on and on, the collisions transfer kinetic energy, which collides more with their neighbors, using the kinetic energy store. And then in the end, the heat is basically spread evenly throughout it. Okay, so in the end, the heat is all spread evenly throughout the metal. Okay. And this is due to lots and lots and lots of collisions. Because in liquids and gases you have particles farther away, um, heat is transferred a bit slower. Okay. Now, how well the objects transfer energy by conduction is known as their thermal conductivity. So some things have a higher thermal conductivity, some have a lower thermal conductivity. So plastic, which are insulators, they have a lower thermal conductivity, which is why exactly we use them as insulators. And then metals have a higher thermal conductivity. Okay. Um, and fluids have a low thermal conductivity as well. But that's fluids don't undergo conduction. So convection, it only occurs in liquids and gases, so it occurs in all fluids. Fluids can include liquids and gases. Usually we think fluids are only liquids, but it can be liquids and gases. Now, let's say you've got particles looking like this. By the process of diffusion, when you heat them, they will generally move away from the warmer area to the cooler area. And this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. And so the fluid in the warmer region actually expands as it starts to heat up, and it becomes less dense than the cooler fluid. And to actually understand how this works in real life, we can imagine that if we had a container, let's say with a liquid or a gas, as we heat up the container, the particles near the heat source actually gain kinetic energy and then they spread out, becoming less dense. So overall, so they're just starting to spread out. And so they collide with the particles above them. And at the same time, these cooler particles start to sink to the bottom, because they start to lose their energy. So the cooler particles are now at the bottom, and they would heat, and this cycle would just keep repeating. And this is what we call a convection current. So the cycle of this, where the cooler and the warmer particles switch places, or the warmer at the bottom go to the top, and then the cooler come back down and heat up, this is called a convection current. And this is in many, like, this is used in many situations. So we see convection currents in oceans, in buildings, in radiators. They kind of all form a convection current. And this is what we're all doing, even when we're sitting under like a blanket at night. To stop the warm air escaping, a convection current is formed. So that's conduction, and then convection. Okay. So the difference is that conduction is only the energy is transferred, whereas in convection the particles move. However, heat energy can also travel without particles. So conduction and convection require particles, but heat energy can also be transferred without particles, and they can travel through a vacuum. So this happens more when energy is transferred by radiation, and looking specifically at when energy is carried by something called infrared waves. So all objects are continuously, they are emitting and absorbing radiation. And the hotter an object, the more radiation it has. So this is why when you put your hand over a barbecue, even if you're not touching it necessarily, you will emit infrared radiation. So because of that, you will get hot even if you're not directly touching it because there's infrared radiation. So this is looking at conduction, convection, and radiation. So we've covered a lot, and hopefully these images help you to kind of consolidate these topics in your brain. When you see an infrared wave, you can kind of remember how that links to radiation, or when you look at a convection current, um, as a radiator, you can kind of link it to things. So hopefully that all makes sense.